Welcome all of students. Welcome to come to hear today's lesson, that is the relationship between resistivity and resistance. So the objective of this set of virtual lab experiments is the difference between resistivity and resistance will be explored. So here will come. This is the resistance, and this one is resistivity, the length of conductor or the wire, the area, the cross-sectional area. When to be fixed, the resistivity, it will be constant, that is 0.5 ohm centimeter. Let to be increase the length of wire, when to be increased the length of wire or the length of conductor, the resistance is increases. So the resistance of a metal wire or conductor wire at a given temperature is depending on the three factors. The other factor is, one of the factor is length of conductor, which is directly proportional. When to be increase the length of the conductor, if the length is doubled, so it does the resistance. It means what? The resistance is also what? Increases. So the resistance also increases. When the length of the conductor is decreases, okay, the resistance is also what? Decreases. Welcome to an area, the cross-sectional area of the conductor. When the cross-sectional area of the conductor is decreases, the resistance of the wire is what? Increases, which means the resistance is inversely proportional to the cross-sectional area of a conductor. So a wire with twice the cross-sectional area will have only half of the resistance. It decreases by half. To be increasing the area or the cross-sectional area of the conductor increased by double, okay, the resistance will decrease by half, which means the resistance is inversely proportional with the cross-sectional area of a conductor. So we'll come to back into the circuit construction in DC circuit. So here it is the resistance, the wire resistivity, here in the middle, in a thin one, in a lot. So to be here in thin mean the resistivity of the conductor is nil, and to be increasing a lot. So the length of wire, when it is increases, the resistance of the wire or the conductor is what? Decreases. Let to be, when it is nil, the resistivity is 0, okay, and when to increase the length of the conductor is to be seen or observing no different in brightness of the lamp, no different. Let to be give some amount of resistivities of wire, when to be increase the length of conductor, okay, the brightness is what? Decreases. To be increasing the length of the conductor, the resistivity is it to be set here. So the resistance is what? Increases, which means the brightness is decreases. Which indicates that resistance is inversely proportional to what? Current. It's Ohm's law. Ohm's law means resistance at a constant voltage or potential difference inversely proportional with current. So to be the length increases, the brightness is what? The brightness lamp is decreases. And to be decreasing the length of the wire, okay, the brightness is what? Increases. Okay, let to be measure ammeter to be connect ammeter, and here the ammeter 1.32 ampere current to flow in this circuit, then to be increasing the length of conductor. Okay, the resistance of the wire is increased and the current is decreases here 0.93 ampere. And to decrease the length, the current flows the circuit, or the brightness is increases, which means the flow of current is increases, which is 1.45 ampere. You see, again and again. Okay, here the current is decreases, mean current decreases, which means resistance increases, and the brightness decreases. When to be the current increases, the brightness what? Increases. So again here, when the area or the cross-sectional area of the conductor increases, the resistance will what? Decreases. This one is the conductor area, cross-sectional area, the conductor sample. When it is increase, the resistance, okay, it will be what? Decreases. And to be decreasing the cross-sectional area, the resistance, it opposes the circuit, the current is what? Increase. Welcome to back to resistivity. When the resistivity of the resistance increases, the resistance is increases. When the resistivity increasing, mean the material is coming to back insulator. It cannot be what passes the circuits, or cannot be past the current. Okay, when to be decreasing, mean that material is coming to conductor, is perfect conductor. Okay, the resistance decreases, which means the current flows through the circuit is increases. This is the relationship between resistivity and resistance. So to be concluding that today's lesson, what resistivity is directly proportional to the resistance. So the material or the conductor from which the wire is made mean resistivity. For example, copper is a better conductor than what? Iron. So copper is more conductive than iron. So the symbol of resistivity, that's the Greek letter rho, is a constant, which the value is depending on the material from which the wire is made or the conductor is made. So the resistivity of most of a metal or a conductor are the range of 10 to the power of -7 ohm meter to 10 to the power of -8 ohm meter. This is the gap between them. So within a large resistivity, the conductor electricity less well. It cannot be passed well. And the resistivity of an insulator may be 10 to the power of 50 ohm meter, 15 ohm meter. So repeat these activities with the different lengths of wire and observe the changing intensities of light. And let to be increasing the length, okay, increasing the length, what the brightness is decreases. When to be decreasing the length of the conductor, okay, the brightness is increased. Thank you. Goodbye, students. Goodbye.